Regular preventive inspection of the electrical system will help to ensure its efficient and continuous operation. The source of electrical energy, the battery, must be maintained in proper condition to operate the starting motor, as well as the lighting system and electrical accessories, and the ignition system. Included in the ignition system are the coil, the distributor, and spark plugs. The generator, with its output controlled by a voltage regulator, must keep the battery charged. Since the entire system depends on the battery, begin by checking each cell with a high-resistance sensitive voltmeter. Fully charged cells should register approximately 2 2/10 volts. Cells should not vary by more than 0.15 of a volt. Check the overall battery voltage. A 3-cell battery, fully charged, should test approximately 6 5/10 volts. Record the voltage readings on the inspection report. Next, test the specific gravity of the electrolyte in each cell. Use a hydrometer equipped with thermometer and temperature correction scale. Fully charged cells should show a specific gravity of 1250 to 1280. Make allowance for battery temperature using the hydrometer correction scale. If the reading is low, 1220 for example, the cell is being undercharged about 50%. Record the hydrometer readings on the report. Check the liquid level of each cell and add distilled water if necessary. To avoid overfilling, use a self-leveling syringe. Rest the tip on top of the plates and force the water in. Any excess is automatically drawn back into the syringe. Check cables and terminals for tightness. Remove corrosion with a stiff brush. Wash the battery with a weak solution of soda and apply anti-corrosion compound to the terminals. To inspect the starting motor, first remove the cover band. Check the length of the brushes. Those worn to less than half their original length should be replaced. Examine the commutator for high mica, flat spots, or pits. When using the screwdriver, be extremely careful to insert the blade only at the metal risers. Do not touch the commutator or the wiring. If the commutator is dirty, switch on the starter and clean it with a piece of double-aught sandpaper wrapped around a stick. Never use emery cloth. Check bushings of the starter housing for radio play. These show no appreciable play. Before testing the starting switch, disconnect the ground strap from the battery to prevent short circuit. Remove the switch and carefully inspect the terminals. Switches with damaged terminals should be replaced. See that all connections are tight. Note the condition of the starting motor and switch on the report form. Inspection of the generator is generally similar to that of the starting motor. Check the brushes. This one, less than half its original length, should be replaced. To replace brushes, the generator should be removed and work done at the bench. To properly seat new brushes, hold a seating stone against the turning commutator. Particles of stone are spread beneath the brushes, seating them very quickly. Inspect the commutator for flat spots. If it has thrown solder, the armature is overheating and must be repaired or replaced. Otherwise, clean the commutator with double-aught sandpaper. Never use emery cloth. Springs with improper tension cause excess wear and should be replaced. Now, unhook the fan belt from the generator pulley and check the armature shaft for play or roughness. As a further test, run the engine and check for unusual vibration which might indicate roughness in the armature shaft bearings. Check the fan belt for wear and for proper tension. About 1/2 inch of deflection is correct. Be sure mounting bolts are tight. Check tightness of the terminals. Now make a quick check of low-tension wiring around the engine, particularly between generator and voltage regulator. Look carefully for worn insulation, loose or broken wires, and loose connections. Check the spots where wires may chafe against metal parts. Check the lighting circuit. With the headlight shining on a wall or panel, operate the floorboard control switch to see that both lower and upper beams are responding correctly. While lights are on, check the ammeter. Tap the glass lightly if the indicator is sluggish. To check adjustment of sealed beam headlights, turn on the high beam. The center of the zone of highest intensity should fall on intersecting lines fixed according to manufacturer's specifications. No extra adjustment is needed for low or traffic beam. With the light switch off, check action of the stoplights. Each stoplight should cause a discharge of about 1 ampere. Turn on the ignition switch and make sure the gas gauge is working. To check the temperature gauge, warm up the engine for about 10 minutes. The indicator should show normal operating temperature. Be sure the horn operates properly and that mountings are tight. Report the checks made for generator, wiring, and electrical instruments. You are now ready to conduct a series of tests on the voltage regulator. To test the cutout, disconnect the battery lead wire, and since it carries live current, wrap the end with tape. Next, hook up a voltmeter between the regulator terminal and hold-down screw. At the same time, connect a tachometer to the engine. Run the engine at idle speed. If the generator cutout is open, as it should be, the voltmeter will indicate 0. Now increase the engine speed until the reading is positive. This indicates the cutout has closed. Record this reading. Also record the speed at which the cutout first closed. Now to test the voltage regulator, increase the speed to 1,000 RPM and note the voltage. Compare this with the manufacturer's specification. To test the current regulator, hook up an ammeter to the regulator. The battery is still disconnected. Add resistance to simulate a partially discharged battery. Run the engine at 1,000 RPM and observe the charging rate. Now eliminate the resistance and connect the ammeter lead to the battery wire. Again, run the engine at 1,000 RPM and observe the charging rate. Compare this with the dashboard ammeter. Both should register approximately the same. To check the general condition of the wiring, battery, and starter, restore the battery lead and connect a voltmeter across the regulator. Take a reading with both the starter and ignition off. Now, connect the voltmeter across the starter post and starter base, and with the starter off, observe the voltage. Next, run the starter half a minute with the ignition off, and again observe the reading. Report all readings and compare with the manufacturer's specifications. Excessive voltage drop may indicate poor battery condition, defective cables, or connections. Another important step in preventive maintenance is the checking and testing of the ignition system, which must be in the right order to fire the fuel mixture at the correct time. Begin your inspection with the spark plugs. Be careful not to break the porcelain insulators. For efficient operation, plugs must be free of carbon and oxide deposits. Clean dirty plugs with a blast-type cleaning machine. If the plug is properly cleaned, the lower end of the insulator will appear white. Measure electrode gaps with a round feeler gauge. Make adjustments by bending the outer electrode, never the center one. In replacing, provide each plug with a new gasket. Inspect high-tension cables for corroded terminals and cracked insulation. Check for corrosion at the distributor cap sockets. This cable shows evidence of corrosion. Use a stiff brush to clean the corroded sockets. Replace the corroded cables. Inspect the distributor cap for cracks. A magnifying glass is often helpful. Minute cracks, often caused by moisture, may result in high-tension leakage. Check the rotor to see that it fits snugly and is not worn. To check the automatic advance mechanism, turn the breaker cam in its normal direction. It should move freely and return when released. Check the freedom of action of the vacuum advance mechanism. This mechanism, known as the vacuum unit, works off the vacuum line. Its principal parts are a diaphragm and spring. When the unit is advanced by hand, it will return easily if the spring is in good condition. Place a small dab of Vaseline on the cam. Use care. Too much will damage the contact points. Apply a drop of light engine oil to the ignition point arm post and the rotor wick. Inspect the breaker points. These are in good condition. Burned, badly worn points should be replaced. To test the breaker point contact resistance, connect a voltmeter to the distributor. Turn the engine until the points are closed. Turn on the ignition and read the voltage. Any noticeable reading indicates high point resistance. In this case, none is indicated. To check the ampere draw of the coil, disconnect the primary coil lead at the distributor. Connect an ammeter between the coil and ground. Turn on the ignition and observe the meter. The coil should draw about 4 amperes. Enter pertinent data in the report. It's advisable to remove the distributor occasionally and check for end play in the bushings. One approved method of setting breaker point openings is with the cam dwell meter or synchroscope. The meter indicates in degrees the cam angle at which the points are closed. Adjust the points until the reading corresponds with manufacturer's specifications. Condition and capacity of the ignition coil may be tested with an adjustable gap meter. The coil should always be tested at normal operating temperature. A spark of the correct length indicates that the coil is in good condition. A test meter is often used to check the condenser. In this case, the intermittent flash of neon reveals a leaky condenser. Make your reports complete and comprehensive. Remember that careful maintenance of the electrical system is necessary to the efficiency of any vehicle.